Yeah, hello one more time. For those students who wasn't present, my name is Maxim Щерба. I'm a professor of electrical engineering department, and we have a new discipline which is called the theory of electrical circuits and signals. It's some combination of physics, mathematics, and electrical engineering, and the main purpose, first of all, to look through the generation, transporting, and consuming electricity. Also, to deal with general mathematical approach, mathematical tools for building model and solving equation for some real objects. And also, according to physics, look through what general assumptions do we have, which assumptions should we make to simplify our mathematical model, and which assumptions could be neglected, which assumptions should be neglected, but which physical process should be used inside mathematical model to make all calculation correctly. What we have about materials, we are having 18 lectures, also practical and laboratory classes. About, I think I see Omar also connect to us. Hello.
Do you hear me?
Yeah, I hear you. Nice to meet you.
Pleasure to meet you too.
Thank you. Yeah. Your name is Omar, yeah? I'm speaking correctly?
Right.
Everything? Okay. If something wrong, please correct me. Then let's continue. About materials. We will have a couple of English books, starting from this one. I will send it for you. Not all of this lecture we will use, but some of them will be quite useful. And also, we'll solve some practical problems. Yeah. We'll solve some practical problems, and our main goal, our main idea to make general overview about mathematical tools that we have and which type of equation we deal with, starting from algebraic equation, then moving through complex numbers, then moving through differential equations and a differential equation in partial derivatives, and try to make them as simple as possible and to solve them in the simplest way. It is our mathematical goal. And this is made for building mathematical model of some real objects. For example, how the process works. Let's propose that we have some object, for example, flashlight, just general simple flashlight that we take outdoor for our purpose. what do we have inside? We have inside a lamp that gives us light, some lamp. Also, there is a source of electricity inside as batteries, and they are connected inside this flashlight in some way, and we have switcher to turn it on or off. It is how some simple physical, some simple apparatus then that we want to model. Then, if we need to calculate something, we should build mathematical model of this apparatus. And building of mathematical model, it is always two sides of a coin. First of all, you should make it as much accurate as you can. Also, you want to make it as simple as you can. And for accurate calculation, it should be detailed, but for simple calculation, it shouldn't be detailed. That is why in any model, some physical processes should be neglected, but some physical processes should be taken in account. And in most situations, the harder thing to make the decision what physical process should be neglected and what physical process shouldn't be neglected. How we could represent these apparatus using mathematical model using such called as electrical circuits. It is some overview of these elements to make calculation which type of lamp should we take, which type of batteries should we take, and also what wires should be inside. As these two sources of electricity, source of voltage batteries, we could point just like that. About pointing, about which elements should be drawn in which way, we will speak a little bit later. Just for now, the main idea how we do it. Also, we have lamp as some consumer, as some load. We could point it as resistor. Lamp. This is our electromotive forces as batteries, and some wires that connects our element inside. These wires also could have some resistance. Lead point is R wires, and some switcher connector as key. To turn on or turn off our lamp. Just general circle. And this circle is solved is the simple way, just using linear algebra. If this battery on direct current and they are on direct current, making the constant value of voltage, we could in one formula find what current do we have here and which process do we have inside. But for building this model, we have lots of assumptions hidden inside it. Which assumptions do we have? What we are speaking about? Generally, in electrical engineering, we could divide all elements on sources and consumers. Sources and consumers. And then the question is what source do we have? What type of energy, what type of electricity it gave to us? It could make constant value. It is called direct current, DC. That is mean that value of voltage and current will be constant anyway, in any time point, sorry. And it could be variable. But if it's variable, if it is variable, then the main question, what type of variable signal do we have? Because it has lots of variance. It could have some periodic oscillation, or it could be non-periodic without any repeating in time. If it is periodic, then does it have some form which we could write as some simple mathematical equation or not? Is it, for example, sinusoidal? Or it isn't sinusoidal? Because if it's sinusoidal, it is quite easy to deal with, quite easy to calculate. Generally, all type of periodical signal is called alternating current, but generally we try to use sinusoidal alternating current. It is the best way to transport in electricity. If it is not periodical signal, then the main question, what form of this signal do we have and how to deal with it? Also, speaking about consumer. If we speak about consumer, also, is it constant? Or is it some variable or some function of some parameter? For example, if it's constant, everything is fine. We have just an ordinary number as resistivity or inductance or capacitance, if we speak about coil or capacitor. Also, a little bit later, I will represent detail about all of these elements. Just for now, the main idea. If we have only numbers, if consumer variable, then what type of variable do we have? Is it a function of temperature? Is it a function of applied current or voltage or magnetic field? Any type of function. Also, this consumer could have some space dimension. In one dimension, for example, just a wire without cross-section, if we could neglect the parameter of cross-section. Two-dimensional, if we have some two-dimensional object as plane, or a three-dimensional object if we try to model it detail using all geometrical characteristics. Or we could neglect all these dimensions in space and using material point, and all parameters is concentrated in point. And depending which type of object you are using, determines the mathematic approach that you should use. We will start from the simplest case of direct current signal without any variations. We apply constant voltage and obtain constant current. Then we will move to different variants of variable source. Then we are starting work with constant consumers. It is called linear circles because if our consumer is constant, that is mean that resistivity of object is constant, and such called volt-ampere characteristic, the Ohm law, you could already seen it on a basic physics course. The dependence between voltage and current through some resistivity, it became a straight line. Then it's called linear. Because if we have variable signal, for variable signal, let's take other color, it will be some curve. And this type of consumer is called non-linear. But for now, for more simple situation, we are taking just a constant variable and it is called linear circle. Then also we will neglect any spatial dimensions. We consume that our resistivity is a material point and concentrated in material point. Then returning to our flashlight, we are speaking that we have direct source, the source of constant voltage, for example, 2 batteries. This source gives us constant voltage in time. And this voltage is independent of load of type of lamp that we have. For this lamp, we have constant resistivity as some number. For example, if we have sources, for example, source number 1, source number 2, for example, 1.5 volts each of them, then for resistivity, I don't remember what value should be. Let's assume that it is 100 ohms. Then when we turn it on, connect the switcher, we could find the current that will flow through this system. This current could be found using one formula that is called the Ohm law. Ohm law. And it will be 3 over 100. 0.03 or 30 milliamperes. And the task is solved. We find the current inside the system. We could find also power that is consumed from this source. The power will be square of current on the resistivity, and it will be 30 milli in square or 0.03 in square and multiply on 100. It will be 9, 10 minus 4, 0.09, if I'm not mistaken, in watts, something like that. It is just one representation how we could deal with real object, build some mathematical model using some consumption about constant consumer, about constant source, about neglecting, for example, of temperature or any other external parameters, and build some circle, electrical circle, and calculate it using linear algebra. Then, if our starting basic assumption will be more complex, we will use more complex mathematics, and we will go through it step by step. It is just a general idea, general representation. Then let's tell couple of words about basic definitions. What physical values do we have, and how we deal with it? What type of equations is it connected, and so on and so on. Also, let's write all general definitions that we have. And let's go through the first lecture. What we're dealing with. First of all, if this, our discipline, the theory of electromagnetic circles and signals, we deal with electrical values such as voltage, current, potential, power, resistivity, capacitance, and so on and so on. First of all, it is a potential phi. If we will return to some general physical ideas, we could say that it is an energetic characteristic of specific point of space. It is an energy that we need to move a unit positive charge, energy to move unit positive charge from infinity to a general point, to point that we speak about. That is why if we have one, we could say that it is just an energetic characteristic of a point. If we have second point of a space, if we want to move charge from one point to another point, the energy that should be consumed for this movement, it will determined as a difference of energetic characteristic of these points, a difference of potential of these points, as phi1 minus phi second. This unit charge that we speak about, it is an opposite value to electron. Electron is a negative charge, and the same value but opposite sign. Then for further part of courses about voltage, we will be speaking as a potential difference. Potential is calculating in volts, and voltage also is calculating in volts. And the measurement device that measure voltages called voltmeter, and will show you volts. Then the second general value is current. Current, the rate of charged particles that move inside some move inside some conductor through period of time, or it is just derivative as charge per time through some cross section. You have metal wire as a conductor, flow of charge particle inside it cross section, some surface S, for period of time, for initial point of time. It is coulombs per seconds and pointed in amperes. The rate of charge moving through the conductor. And also the value that connects voltage and current, it is resistivity. I will return to this representation. It is resistivity R in ohms. R in ohms. Or in English, we could write like that, ohm. And it connects current and voltage by the equation that is called the Ohm law. Here it is. And it is the rate how simple the current could move through the wire or through any conductor. The value of resistivity shows the, how it's called, a reaction. I think reaction of our conductor through current flow. And also, what is represented here for better understanding of situation? It's such called analogical analogy representation using water, that resistivity could be represented as cross section of some water tube, and for example, pressure inside water system will move water, some water flow. The water flow, water could be represented as analogy of charge, water flow as analogy of charge flow as current, and the cross section of pipe or characteristic of pipe could be represent characteristic of resistor. And also such method of analogy, it is quite widely used in different parts of physics, because if mathematically for different systems equations are the same, I mean the same mathematically, the same form, then we could substitute one system by another system. What I mean, for here, we represent substitution of electrical system by some water system. Also, there is approach, for example, represent temperature movement, how temperature changes in some system as electricity. Or, for example, in medicine, blood flow inside human body also could be represented using electricity, or magnetic circles with magnetic field could be represented analogically to electric system. Just what we need, because such substitution could simplify our calculation or building of mathematical model. What we need to compare values from one physical region to values with another physical region. For example, if we compare, like here, electricity and charge, electricity and water flow, then water could be compared with electrical charge, pressure that we have, water pressure P, compared with voltage, because as higher pressure do we have, as quicker water will flow. As higher voltage do we have, as bigger amount of charge also will flow. And water flow could be compared with current. And for example, as bigger pressure do you have and higher current flow, as bigger voltage do you have, as higher water flow and current flow you have. The mathematical equation will be the same. Also, for example, for temperature increase, the flow of energy or flow of temperature could be compared with current, and characteristic of systems could be compared with voltage. I think I will show it a little bit later, just not to mix a lot of information in one bucket. Just a physical representation. As smaller cross-section of pipe do you have, as bigger resistivity you will get. For electricity, resistivity is depend from a material parameter, the material characteristic, what type of metal do you have, the length of your wire, as long do you have this wire, and cross-section, surface of your cross-section. As longer wire do you have, as bigger resistivity you will get, as bigger cross-section do you have, as smaller resistivity do you have, as better metal you will get with higher conductivity, or with smaller resistivity, the same idea. As better material do you have, as smaller resistivity you will get. And for now, we are dealing with constant resistivity. All resistivity became constant. It is mean if you have, for example, resistivity 1 ampere, if you will apply 1 volt, you will get current 1 ampere. Apply 1 volt, obtain 1 ampere. If you will apply 2 volts, you will get 2 amperes. Apply 3 volts, obtain 3 amperes, and so on. The linear dependence. But for example, assume that your resistivity depends from current. For example, it is some constant, for example, 2, and multiply on current. the resistivity is function of temperature, and temperature is a function of current. That your resistivity depends from current. Then using the Ohm law, you should write voltage equal current multiplied resistivity, but your resistivity also a function of current. You're obtaining the S square dependence from the current, I square, sorry, not resistivity, here this constant 2. 2 multiply on I, and I square multiply on 2. And for example, if you are taking current 1 ampere, the voltage also, the voltage became 2 volts. But if you are substituting 2 amperes, the voltage not became 4, but became 8. 4 multiplied on 2 became 8. If you are substituting 3 volts, then it became 9, and you're obtaining 18. And so on and so on. As you see, the dependence became nonlinear. And generally, it will be more complex equation because the dimension of this equation will increase, but it will be later. For now, for half of semester, all that we will deal with will be constant resistivity. Then, what also do we have? The resistor as a characteristic of system, characteristic of consumption of electricity. Depending on what type of resistor, what type of book do you have, what type of computer program you have, you could find different of pointing of it. For example, in IEEE symbol form, it is pointed just like this. In Ukrainian literature, more wild use, you will find this pointing, and also could be different forms depending on what type of resistor do you have. Is it variable or is it constant? Could it change its value, and so on and so on. But generally, we will point it like this. Also, the Ohm law that I speak about, connecting 3 main electrical values, and the representation of pointing value of resistivity. We are speaking about direct current, constant source, and the representation of sources. It could be point as battery. Generally, in computer programs, you could find sign marking. Also, it could be pointed like this, direct current or sinusoidal alternating current source. In Ukrainian literature, the most common used, the form like here. Electromotive force with an arrow inside circle, and the direction of arrow shows you the potentials. That is why you could not point as plus or minus. It is understandable that for the arrow direction, that is positive potential, and for opposite direction will be the negative potential. And the voltage which applied to this element equals the such-called electromotive force or value in volts of this element. For example, 10 volts, the electromotive force of this source. And the second type, the source of current. What are the difference? The difference is mathematically. The source of voltage gives you constant voltage, but current could be different. The electromotive force which gives you voltage is constant. But current could obtain any variable. For current source, it is point as two arrows inside circle. It gives you constant current. It means that the value of current equals the value of source, but the voltage which applied to his node, its node, could be any, could obtain any value. In our real life, generally we have voltage sources because we are starting from voltages. For example, in your homes you have sinusoidal, but also voltage sources. But in some specific cases, we could find also current sources. All your batteries, they are voltage sources, accumulators, but in some specific case, we could find current source. What does it mean? For example, we have resistor 10 ohm and other resistor, for example, 100 ohm. Two different resistors. Let's assume that we have voltage source equals 10 volts, and we have current source pointed here as equal 1 ampere. Okay, two types of sources. For first source, sorry. Want to move it. For first source, you are connecting this resistor. What do you have? You have Ohm law that tells you that in first case, current will be electromotive over resistivity, the first one, and you obtain 1 ampere current in the first case. Then return it back and take another one. If you connect the second resistor, the same calculation, but the current will decrease 10 times. It will be 0.1 amperes. Constant voltage, but variable current. Different currents you could get on the load. For the current source situation, the situation will be opposite. You are connecting the resistivity 10, and current should always be the value of source. It means that using the Ohm law, voltage in first case will be value of source, current rate, multiply on resistivity. The voltage will be 10 multiplied on 1 will be 10 volts. In the second case, second voltage will be current rate on the second value of resistivity, and we are obtaining 100 volts. Then, as you see, for voltage source, the voltage always stays the same, but current could obtain any values. For current source, the current rate stays the same, but voltage could obtain any values depending on resistivity. It is two types of sources, two different types of mathematical representation of sources. Here they are. For this point of time, maybe you have any questions, maybe you have to discuss something about what we speak. Is it for now everything okay, everything clear? What is your opinion?
It's clear.
Clear. Okay. Okay, glad to hear it. Further, the material will be more complex. We are starting from the simplest ideas just to generalize them, and then we will move more deeply into the material, and it became more complex. Just if you will look, if you will go step by step, I hope everything will be okay. If you will have any questions, please ask during the lecture. There is no problem. Just in any point of time, ask, please, could you repeat something, or could you discuss something more detail? Everything okay? You haven't wait until I finish some speaking. You could ask any question during the lecture. Okay, let's then move further about main topological moments, how we build mathematical model. Such mathematical model that we represent, it could be built in computer programs, for example, MATLAB Simulink or Multisim, Electronic Workbench, any program which operate with electrical values. We could build such circle model and calculate every values that we need. What the main topological elements are inside model? The structural elements are such called branch. Branch is a serial connection of different elements. The main characteristic that current should stay the same without any additional connections inside. For example, if you will connect something here, this will not be a branch because you have first current, for example, second current, and third current, different currents. Inside one branch, current should stay the same. without any additional connections inside. Without any additional connections. Then the second element, structural element, called node. Node is a point of connection of different branches. How many branches do we have here? All different serial connections of elements we have, for example, between points of connection. First, second, third, number 4, number 5, for example, and number 6. As you see, we have 6 branches here. 6 branches. Also, points of connection. For each branch, we have point of connection. The first one, the second one, the third one, and the fourth one. Generally, we have 4 nodes. But some nodes could be connected all together depending of elements. If in some branch we don't have any elements, as you see here, isn't any element. That is why this is a single wire with 0 resistivity, with 0 ohm resistivity, and the potentials according to physics. If we don't have any resistivity, the potentials should be equal. That is why if the potentials are the same, then these nodes could be connected in one. Generally, each node have specific potential. Potential number 1, potential number 2, and potential number 3. For single wire without resistivity, the potentials will be equal. Then we could call that we have 3 nodes if we will connect them all together. And also other structural element that called mesh. The mesh is a circular connection of branches. It is couple of branches connected circular all together. How many and one branch could be included in different meshes? We have 3 meshes here. 3 meshes and a couple of branches, for example, branch number 2 and branch number 4 are included in 2 meshes simultaneously. It isn't a problem, it is just a topologically view of this circle. 2 sources of electricity and 5 consumers as resistors. By resistor, we could mean any type of object, any consumer, any object that transforms electrical energy for other type. It could transform for heating, for temperature, and could be any heating element, electrical kettle, for example, home heater, and so on and so on. It could be some type of lamp transforming electricity into a light. It could charge some accumulator to obtain chemical reaction. It could be some mechanical system to make some movement as electrical motor, or for example, some turbine or anything else. just to make rotation from electricity. All parts of transformation from electricity to other type, we could name as consumers and as resistors. The opposite transformation, other type of energy into electrical, will be sources. For example, solar power, wind power, atomic power, chemical reaction if we discharging the accumulator, burning of coal or gas will transform other type of energy to electricity, and we could point at it as sources of energy. Three main types. Some authors determine loop and mesh as two different topological structures, but as my opinion, it is almost the same. You could always speak about mesh because mathematically you always speak about the smallest path for current. Some authors tells that a big circle called loop, the smallest circle called mesh, but I think it is not so important. You could always tell just about mesh. And three main structural elements that we discussed: branch, node, and mesh. Also about structural view and mathematical approach for it. It is a single or multi-mesh network, such called. If you have only one current, the same current that flow through all system. Current start to flow and the same rate of current. It is called single mesh. If you have lots of deviations in each branch, different current, because as you see, the current start to flow and will divide on couple of branches. The current will divide on 4 directions. Then the rate will be different. Such type of mesh, such type of network is called multi-mesh because you have lots of meshes inside it. Okay, then about working modes, couple words of working modes, what it means, short circle, open circle, and so on and so on. I think generally on each lecture, we will make a short break between each 45 minutes part. Today we speak about lots of material, and I missed about break. That I think let's make a short one about 5 minutes. We could stay on the same Zoom link. You could stay here. I also will not stop recording, just make a short pause, and just about after a small 5-minute break, we will continue. Okay, just to make our mind a little bit clear.
Okay.
Okay, just 5 minutes. Okay, let's continue.
Okay.
Okay, yeah, let's continue. Generally, our classes will be from 15 minutes after 2 p.m. and as general schedule in KPI, and ends till 10 minutes before 4 p.m. I think about 20 minutes we'll discuss couple of points and then we'll finish. Okay, about working modes. Different working modes. If we imagine some source and consumer, connected all together. If this consumer could be variable, we could obtain all available working modes for our system. If this consumer varies from 0 to the infinity, we will get all available values of currents here. And starting from 0 to infinity, variance of resistivity. And the smallest value of resistivity is 0 is called short circle, just connection between 2 points without any effect of the material. And the highest value of resistivity, the opposite mathematical variant, is called open circle. Sorry, my cats and have 2 cats that they could, yeah.
Hi.
They could. Hi, hello. Yeah, they sometimes could be on our classes. Here it is.
Oh.
Okay. Okay, let's continue. Yeah. What's about these 2 opposite variants? Short circle as 0 resistance, open circle as infinity high resistance, and all other variants will be between these 2 points. Why is it important? Because 2 types of sources, here they are, voltage and current, mathematically they have opposite characteristics, and their short and open circle modes also opposite are 2 opposite mathematical characteristics. What do I mean? I mean that generally voltage source will make constant voltage and has open circle mode. If we don't connect any resistivity to it without any resistivity, it works without consumption of energy in open mode, because if we close it, this source always make the same voltage And if we close it on 0, we will get infinity high current. This source just will be damaged and just disappear. For current source, but if the connection points of these sources are open, then without any consumption of electricity, we only obtain potential phi plus here, phi minus here, without any operation. For the current source, the situation is opposite. This source always try to make current I, because it is a current source. And if we disconnect each points, each connectors, then this source will try to make current through infinity high resistance, because it is a characteristic of source. It is a operating idea of this source. And power of such process will be square of current on the resistivity, but resistivity we have infinity. And the operational power will flow to infinity. This source will overheat and also damage and will disappear from our network. Then it's why, because of it, the current source always stay in short circle mode. In short circle. The current will flow through zero resistance, and the operating power of this mode will be I square on 0 without any consumption, 0 watts. That is why voltage source always stays in open mode and cannot be shortened, and current sources always stay in a short mode. They cannot be opened. Two general differences between structure of source. For any other type of system, if we have inside system lots of elements, it depends of a structure of our system. Which of this mode could be possible or opposite cannot be possible, will be impossible for our system. It depends of the structure. But two opposite cases. What also do we have interesting here? About pointing. If we have electrical connection, we point it as dot, then it means that all wires have electrical connection. If wires don't have electrical connection, they are pointed like here. Without dot, it means that it is two separate wires without any electrical connection. Here. And then a couple words about basic laws, and the next time we will try it on practice. It is quite useful, quite simple, that all methods that we have in electrical engineering, they are based only on 3 laws. only three. It is Ohm law that we speak already, connect current, voltage, and resistivity. And such called Kirchhoff current law, which connects current. It speaks, it is a conservation law that total current that inflow equals total current that outflow. Because current, it is a moving of charge, all charge, electrical charge that appears in some point or in some object should equals all charge that disappears from this object. A charge conservation law. Such formulation is called Kirchhoff current law and tells about total current. And the same voltage Kirchhoff law that is here. Just one moment. No, here it is. Kirchhoff voltage law. It is also energy conservation law. It tells us that total voltage of consumers should equal total voltage of source inside one mesh. Summarize all voltages equals all consumers. And on these three laws, current, voltage, Kirchhoff law, and the Ohm law, all mathematics appear only on three laws. All other is just some transformations, representations, substitution of variables, some mathematical approach how to deal with equation, because equation could be also integral or differential, but generally all these equations are written only on these three laws. And we will speak detail the next time. For today, I think for the general information, it's enough. What we discussed, let's summarize everything what we discussed. We have three main physical values. Voltage in volts, current in amperes, and resistance in ohms. Where it is? Resistance. Resistance in ohms. They are connected using the Ohm law, that voltage equal current multiply on resistivity, or the same as current equal voltage over the resistivity. And they are three main characteristics of electrical system. Also, very important, what type of resistivity do we have? For now, we have constant resistivity. It is called linear circles because of current voltage dependence. It became linear if resistivity is constant. And we will speak about this situation for the first half of semester. All resistors are called passive elements. All sources are called active elements. We could divide on sources and consumers, all elements inside our system. Some pointing of resistors, some pointing of sources, and very important thing about characteristic of source, that voltage source always gives constant voltage and can be operated only in any mode except of short circle, because in short circle this source will be overheated. And the second type, current source. Current source makes the constant current, and applied voltage could be any opposite to the voltage source. And for current source, the open circle mode will be impossible because this source will overheat. Two different situations. Voltage source with constant voltage and cannot be operated in short circle. Current source with constant current and cannot be operated in open circle mode. And structural elements. We discussed structural elements of system as branch, loop, and mesh. And if we have only one path for current, it is called single mesh. If we have lots of meshes, it is called multi-mesh. It is just a general overview about today's lecture. For further on practice and on further lecture, if we get some problem for solution for solving, we are looking on the element presentation and could find source, could find consumers, calculate how many branch do we have, how as a current path, how many nodes do we have as a point of connections, how many meshes do we have as a loops inside this circle, and it determine which mathematic will be used for this circle. And this circle could be represent any real object. It could be, for example, a house with ordinary equipment inside it. For example, any electrical device inside our house connected in one system. It could be a house with lots of flats. Each consumer could represent some owner with own flat and all electrical devices that it has. It could represent, for example, equipment on some factory or a system for transportation, electricity from a generator from some plant to a factory. Or it could represent some mechanical system with generators, electrical motors, and some heater and light devices. It could be any real object that we want to calculate it in terms of current, voltage, power, and resistivity. I think that's all. For today, that's all. Maybe you have any questions, maybe you want to ask something. Everything is okay? Everything is clear?
Yeah, it's clear.
Okay, perfect. You will have this recording on YouTube channel. Link I will send on your emails, also in your group. Also, I see another student is connected. Abdullah Hamed, yes? If you hear me. Okay. I think we will get in touch a little bit later. Then I see almost all 4 from 5 students for some period of time was present. Then I see them. Okay, then thank you for your attention. Wish you a nice day. Wish you good luck, and see you the next week, the same time.
Thank you. See you. Have a nice day.
Thank you. Same to you. Goodbye.